Hello friends, good morning. I welcome you all for my YouTube channel. Okay, so from past previous sessions we are discussing about matrices as we all know. So let us continue with the same thing. In previous class we have started exercise 3.4. Right, we have also completed 8 problems. Now let us start with the ninth one. So here also we need to find the inverse by using the elementary transformations. Okay, so first let us define this matrix. Let A is equal to 3, 10, 2, 7, and what we know, I can write A as equal to I into A. So that is 3, 10, 2, 7, 1, 0, 0, 1, which is nothing but identity matrix, into A. I have written A in terms of A is equal to I into A. So now observe here, A11 is 3, we need 1 there. So I need to subtract 2. From where I will get 2? That is from row 2. So first row 1 changes to row 1 minus row 2. So 3 minus 2, this is 10 minus 7, row 1 is 10, row 2 is 7, here 2 and 7 as it is. Here also same thing applies, 1 minus 0, 0 minus 1, 0, 1 as it is. Then this will be 3 minus 2 is 1, 10 minus 7 is 3, 2, 7, okay. So now we got 1 here. Now we can make this 2 as 0. How to make this 2 as 0? Operating with row 1, right? Row 2 changes to row 2 minus 2 times of row 1. So 1, 3, this thing remains as it is. 2 minus 2 into 1. Two minus 2 into 1, and here 7 minus 2 into 3. So that will be equal to 1 minus 1, 0 minus 2 into 1, and here 1 minus 2 into minus 1 into A. So this will be 1, 3, then this is 0, this is 1. 1 minus 1 minus 2 minus of minus 2, that is plus 2, 1 plus 2 is 3 times of this is A. Right, we got 0 here, we got 1 on the diagonals, we have only 3 that should be eliminated. So that can be done by R1 changes to R1 minus 3 R2. So this will be 1 minus 3 into 0. 1 minus 3 into 0 is 1. Now 3 minus 3 into 1. R1 is what? 3 minus 3 into R2, 1. So that will be what? 0. Here 0, 1 as it is. Now R1 is what? 1 here minus 3 into what is R2? minus 2. So what will be the value? Minus 3 into minus 2 is plus 6. 1 plus 6 is 7. So I will get 7 here. Then same thing. R1 is what? Minus 1. What is R2? 3. 3 into 3 is 9. So minus 1 minus 9 is minus 10. And this is minus 2. This is 3 into A. So I have I here, I have some matrix and I have A. So that will resemble I is equal to A inverse into A. So I have A. So whatever matrix here I got, that should be our A inverse, required A inverse. So what will be my A inverse? A inverse will be this matrix 7 minus 10 minus 2 3. So this will be my A inverse. If you want, you can cross verify with the formula A into A inverse is equal to I. Definitely you will get the value as I. So this is required A inverse. Okay. So this is how we need to proceed. Right. Our motto is to convert to transform the matrix on the left hand side into identity matrix. Once we do that, whatever matrix we get on the right hand side, that will be our required A inverse. Whatever matrix we are getting on the right hand side will be our required A inverse. Okay. So let us proceed with this one. Okay. Here also we will define it. Let A is equal to 3 minus 1 minus 4 2, and we know that what we know, A can be written as A inverse into, sorry, not this one, A can be written as I into A. A can be written as what? I into A. So that is 3 minus 1 minus 4 2. What will be I? Definitely 1001 into A. Okay. So this is arranging the required matrix into given form. Now here at A11 we have 3. So definitely we should get it as 1. So if I go through row transformation, then also I will get 1. But the problem is it will take long time. It will take long time and the process is lengthier. Right? What I need to do here? 3R1 minus 2R2. 3R1 will give me 9. 2R2 will give me 8. So 3R1 minus 2 plus 2R2 will give me 1 here. So but that will consume lot of time. Right? So here in this case, let's try with column transformation. And one thing in majority of the problems, right, whenever you opt any row transformation, the entire problem should be carried out by row transformation. And in any of the problem, if you opt column transformation, so entire problem should be finished with column transformation, right? So very rare cases we use both of them in the same problem, but in general we use any one of the transformation, either row or column. Okay. So here I can write C1 changes to C1 plus 2 C2. So what happens here? Only C1 will change. C1 means these values, right? C1 is what? 3 plus 2. C2 is minus 1. And here C1 is what? Minus 4 plus 2 into C2 is what? 2. And minus 1, 2 remains as it is. Here also same thing. C1 is what? 1. C2 is what? 0. And here C1 is 0. C2 is 1. This 0, 1 as it is. with A. This will give me 3 plus 2 into minus 1, that is 1, minus 1, minus 4 plus 4, 0, this is 2. 1 plus 2 into 0 is 1, this 0 as it is, 0 plus 2 into 1 is 2, 1 as it is, A. Alright, so now we got 0 and 1 here, here we have 2, here we have minus 1. Alright, so we need to convert this 2 into 1 and we need to convert this minus 1 into 0. Now as we have opted column transformation, here also we need to go through column transformation. But if I try to change this 2 as 1, then what happens? This value also will be affected. If I divide this column throughout by 2, then what happens here? Minus 1 by 2 will come and this 1. So it will be tedious. So let's try to make this one as 0 first. Right? So column 2 changes to column 2 plus column 1. Column 2 changes to column 2 plus column 1. So what remains here? 1, 0 as it is. There is no change in column 1. Column 2 only will change. Column 2 plus column 1. What is column 2? Minus 1. Right? This is 2 plus 0. Right? 1, 2. This column will remain as it is. And here 0 plus 1 and 1 plus 2A. So this is nothing but 1, 0, 0, 2, 1, 2, 1, 3, A. Okay? Okay? So minus 1 plus 1 is 0, 2 plus 0 is 0. 0 plus 1 is 1 and 1 plus 2 is what? 3. So now okay, so this has to be converted as 1, right? So for this what we will do? We will have to change this 2 into 1. We need to divide the entire column by 2. Okay, so we need to divide the entire column by 2. So what happens if we divide by 2? Just a minute, just a minute. Okay, fine. So if we divide it by 2, one by 2 column 2 will be equal to 1 2 as it is. 1 by 2 will be 1 by 2 and this is 3 by 2 times of A. So we got I, we got A. So this is how we need to proceed. Right? What is our A inverse? This is our A inverse. Is that clear? So take it down, pause the video and take the notes down. Okay friends, I hope by this time you might have got the idea how to find the A inverse, how to find any inverse of the matrix. Okay, so now let us apply the same technique and try to find the inverse of these two matrices. Okay. Let A is equal to 2 minus 6, 1 minus 2, and we know that A can be written as I into A. So that is 2 minus 6, 1 minus 2 can be written as I into A. Can be written as I into A. Right? So now our main motto is to convert this into identity matrix. So what should be there in identity matrix? Diagonal element should become 1 and other element should become 0. Right? So for the diagonal element to become 1, this should become 1, which can be operated with row 2. If we apply row elementary transformations, then operating row 1 with row 2 will make this value as 1. Right? But in this problem, if you go through row transformations, it will take long time. Definitely you will get the answer. You can try that one. Right? But it will take long time. So let us go with column transformation. Right? So let us try to make this as 0. In column transformation, initially we cannot make this as 0, right? Because of proportionate terms. So let us try to make this as 0. This cannot be made as 1. This cannot be made as 1 by column transformation directly. So let us try to make this as 0. So when we make this as 0, so what will be our transformation? Column 2 changes to column 2 plus 3 times of column 1. Column 2 changes to column 2 plus 3 times of column 1. So what will be that one? So column 1 will remain as it is, 2 and 1. Okay. And what will be about column 2? That is minus 6 plus 3 times of column 1, 2. And this is minus 2 plus 3 times of column 1, that is 1, is equal to 1, 0 as it is. And here column 2, that is 0 plus 3 times of column 1. And here 1 plus 3 times of column 1, that is 0. A as it is. Okay, fine. So now this is 2, minus 6 plus 6 is 0, 1 here, minus 2 plus 3 is 1, this will be 3, this will be 0, this will be 1 and A. So now we got 0 here. Now we can make this as 1 by dividing if we divide row it will become 1, but as we have opted column transformation, so we cannot apply row transformation at this stage. So we need to apply the column transformation. Let us try to make this as 0. Then only it will be convenient for us to make this as 1. So column 1 changes to column 1 minus column 2. Column 1 will change to column 1 minus column 2. So what will be my value? 2 minus 0, 1 minus 0, 0, 1 as it is. And here 1 minus 3, 0 minus 1, 3, 1 as it is. Okay. What we are having here? 2 minus 0 is 2. This is 0. Minus 2, 3, minus 1, 1, A. Okay. Just take some space out of here. Okay. Fine. So we got 2, 0, 1, 1. Right. So what we need, this element to be transformed into 1. And this should be transformed into 0, right? So how to do that? So C1 should change from right? C1 should change from C1 by C2. This should be 1, this should become 0, right? So let us try to make this as, sorry, this is already 0 here. 1 minus 1, this becomes 0. So what only thing left over is, I need to convert this to as 1, right? So for that I can apply C1 changes to 1 upon 2 C1. C1 changes to 1 upon 2 C1. So one upon 2 into 2, that is what? 1. Then 0 upon 2 is 0. Then 0 upon 1, sorry, this will remain as it is. 0, 1 is equal to, this is what? Minus 2 divided by 2 will be minus 1. Minus 1 divided by 2, minus 1 by 2. 3 and 1 as it is. Multiplied by A. So we have I is equal to something into A. Therefore, A inverse can be written as minus 1 by 2, 3, 1. Minus 1, then 3, then 1 by 2, minus 1 by 2 and 1. So if you make this as identity element, then definitely you are going to get the inverse matrix. So if you want, you can verify with A into A transpose, A into A inverse is equal to I, right? So take down this one, pause the video and take it down. Then we can continue with the 12th one. Okay, I hope friends you have taken down that one. So let us continue with this 12th one. Okay, let's continue with this 12th one. Okay. Let A equals 6 minus 3 minus 2 1. We know that A is equal to I into A. So therefore I can write 6 okay, fine. So now I need to convert this into 1. I need to convert this into 1. If I go through column or row transformation directly, it is not possible to convert into 1. If I operate with second column or if I operate with second row or second column, this is never going to be 1. So in that case, what we need to do? We don't have any other option. Divide the first row. Suppose if you want to operate with second row, what happens? Right? Multiplying this by any number will not make this as 1. For example, if I multiply this by 2, here I will get minus 4. If I add this 2 rows, 6 minus 4 will be 2. If I multiply this by 3, I will get minus 6. If I add the 2 rows, I will get 0 here. So similarly is the case with this column also. So whatever I take the multiples of, whatever may the multiples of second row or second column, that will not give me the value of A11 as 1. It can be made easily as 0 but not as 1. So what we need to do here, in that case, divide the whole row by 6. Then only we are going to get the value as 1. R1 changes to 1 upon 6 R1. So what happens here? 1 minus 3 divided by 6 is minus 1 by 2. then minus 2, 1, then 1 by 6, 0, 0, 1, right, into A. So now this is 1, I need to convert this as 0, so I can take row 2 changes to row 2 plus 2 times of row 1. Times of row 1. Row 2 changes as row 2 plus 2 times of row 1. Right? Row 1 will remain unchanged. 1 minus 1 by 2. Row 2 is what? Minus 2 plus 2 into 1 minus 2 plus 2 into R1, and here 1 plus 2 into minus 1 by 2, right, and this is equal to, here what we get, one by 6, okay, only row 2 is changing, no issues. Row 1 will remain as it is. Row 1 is what? 1 by 6 and 0. Okay. And row 2 is what? 0 plus 2 times of 1 by 6, and here 1 plus 2 times of 0 into A. So now what happens here? So you can see 1 minus 1 by 2. Minus 2 plus 2 is what? 0. Here what we get? 2 and 2 cancels, minus 1 remains. 1 minus 1 is also 0. This is 1 by 6, 0. This is 2 into 1 by 6 is 2 and 6 cancels. What remains is 1 by 3, and here 1 into A. Now observe, row 2 has the values as 0 and 0. Both the entries in the row 2 is 0. So it is not possible to convert this matrix into identity matrix. So whatever transformation you apply, it is not possible to convert this into identity matrix. Is that clear? So in that case, what happens, if any row or any column, entire elements, if you come across as 0, then this to be understood that you cannot convert that matrix into identity matrix. Okay, so therefore A inverse does not exist. A inverse does not exist. Is that clear? So whatever operation you apply, you will definitely get 0 as 0 in any row or any column here. Not only these operations, you apply any operation, definitely you are going to get 0 in any row or any column in this particular problem. So definitely it is not possible for us to find the inverse, or inverse will not exist for this particular problem. Okay, so you pause the video and take the notes down. So friends, I hope you understood those previous problems. Let us solve this 13th one. Let A is equal to 2, minus 3, minus 1 and 2. We know that A can be written as I into A. that is 2 minus 3 minus 1 2 will be equal to 1 0 0 1 8. So now we have 2 here, that has to be converted into 1. How we need to convert how can we convert this 2 into 1? By adding row 1 and row 2. So I can write row 1 changes to row 1 plus row 2. Then what I will get? 2 plus of minus 1, then minus 3 plus 2, this is minus 1, this is 2, will be equal to 1 plus 0, 0 plus 1, 0 and 1 times of A, because R1 plus R2. Okay, so what will this give us? 2 minus 1 is 1, minus 3 plus 2 is minus 1. Okay, fine. So now I am having minus 1 here, I need 0. Okay, R2 changes to R2 plus R1. R2 changes to R2 plus R1, or R1 plus R2. So what happens? 1, 1 here. Minus 1 plus 1, 0. 2 minus 1 is 1. 1 plus 0, 1. 1 plus 1, sorry, 1 and 1 as it is. R2 should be changed. 0 plus 1, 1. 1 plus 1, 2 times A. Okay. Now I have 0 here, I have 1 here, I have 1 here. Only this thing is to be changed. Okay. So I can write R1 changes to R1 minus R2. One minus 0 is 1. 1 minus 1 is 0. 0, 1 as it is. R1 minus R2. What is there here? 1 minus 1 is 0. 1 minus 2 is minus 1. Right? So 1 and 2 as it is. So this is nothing but our required A inverse. So what we have done here, initially we have taken the matrix A and equated it to this equation. So A is equal to I into A. A is 2 minus 3 minus 1 2. I is 1 0 0 1 and A as it is. So we want this to be changed as 1. So R1 changes to R1 plus R2 will give me 1. Right? What happened here? R1 changes to R1 plus R2. What is R1? 2. What is R2? Minus 1. 2 plus of minus 1. What is R1 here? Minus 3 plus R2 is what? 2. Here what is R1? 1. What is R2? 0. So 1 plus 0. What is R1 here? 0. What is R2? 1. So 0 plus 1. And remaining as it is, 2 plus of minus 1, that is 2 minus 1, we will get 1. Minus 3 plus 2, so we will get it as minus 1. Okay. Then here 1 plus 0 is 1, 0 plus 1 is 1, 0 0 as it is. Now we got 1 here. I need to change this as minus 1 I am having here. I need to change it as 0. So how come it is possible? R2 should change to R2 plus R1. Right? So this is minus 1. 1 minus 1 as it is. So what we get here? Minus 1 plus 1, 0. And what will be 2 minus 1? That is 1. And here 0, 1, 1 as it is, 0 plus 1, 1, 1 plus 1 is 2. Now I need to change this side. I need to change this as minus 1 I am having. So what I should get? R1 should change to R1 plus R2. Then what happens? 1 plus 0, 0. Minus 1 plus 1 is 0. So that will be there. And here 1 plus 1 is, this will be 2. Right? And 1 plus 1 is, it will be 3. The slight change. Right? 1 plus 2 will be 3. Remaining everything will remain as it is. So what is my A inverse? A inverse will be 2, 3, 1, 2. So this will be my required A inverse. Is that clear? So if you verify A into A inverse, definitely it will give you the value of I. Okay. So this was about this 13th problem. Right. So we have solved many 2 cross 2 problems. Right. Nearly 7 to 8 problems we have solved. So with the same idea, you try this one. Right. So also you know that it is asked to find A inverse if it is existing. Right. Previous problem we have seen that it is not existed. So it is not compulsory that every problem it should exist. If it is existing, you find the value. If it is not existing, you can write it as not existing. So how do you come to the conclusion that it will not exist? So any row or any column will have all the entries as 0. If that is the case, then it will not exist. Okay. So in that case, you can write it as not existing, or else once you are reduced the LHS matrix as identity matrix, the matrix on the RHS part will be your required A inverse. Okay. So fine, with the same knowledge, you try to solve this one and let me know what is the answer. Alright. So you can comment the answer in the comment box. Right. I will get back to you. Okay. So with this, we will wind up this session. So another 3 to 4 problems are left out. Right. So those are all 3 cross 3 matrix. So we'll take up those in tomorrow's session. Okay. So we'll take up those in next session, and we'll wind up this unit. Is that clear? So one more session is required to finish the entire matrices. Is that clear? So according to your NCERT syllabus, everything will be finished. All the concepts of matrices will be finished with one more session. Right? So now what you do is you pause this video, take this thing down, right, and try to solve this one by yourself. Okay? Thank you.